Bismillahirrahmanirrahim. Today we are gonna teach you about chapter number first of chemistry, that is stoichiometry. Stoichiometry is about the calculation that is based on chemical reaction or balanced chemical reaction or balanced chemical equation. To before start the stoichiometry, we will first discuss about the term mole. So before we go to mole, here mole is just like a term like dozen. In normal life, we know that dozen is used for 12 similar things. In life, if we have, for example, 12 bananas, we call it we have 1 dozen banana. 1 dozen banana. If we have 12 keychains, we call it dozen keychain instead of 12 keychain. So same way there is another term that is called gross, that is used for 144 similar things. So if we have 144 similar things, we will say that I have 1 gross things. If you have 144 watch, we can say that we have 1 gross watches. Now mole is the term like dozen and gross, but it is used for when we have 6.023 multiplied 10 raised to power 23. This is a huge number, like this is 6023 1 2 3 4 5 6 7 8 9 up to 20 21 23 up to 20. This is a huge number. So if we have that number of things, we will call it that we have 1 mole. If someone has 6.023 multiplied 10 raised to power 23 rupees, they can say that I have 1 mole rupees. Or if there is 6.023 multiplied 10 raised to power 23 atoms, we can call it that it is 1 mole atoms. Now for atoms, we in book or anything, we represent the 6.023 multiplied 10 raised to power 23 number by Na, and this number is called Avogadro number, discovered by scientist named Avogadro. So that's why we call it Avogadro number. So to avoid the repetition of this number in writing and calculation and everything, we use the terms Na. So by using Na, we can bypass the use of 6.023 multiplied 10 raised to power 23. So Na equal to 6.023 multiplied 10 raised to power 23 similar things are equal to mole. Remember this. Now if for atoms, 1 mole atom is equal to Na atom. Like for Cl, we can say that we have 1 mole of Cl, its number is NaCl, or 6.023 multiplied 10 raised to power 23. 1 mole Na means that we have Nm Avogadro number of sodium. 1 mole hydrogen means that we have Avogadro number of hydrogen atom. And for compound, 1 mole H2O means that we have 1 mole of H2O, and 1 mole NaCl means that we have Avogadro number of NaCl. This was the relation between mole and its number. Same like the relation between the mass. So we know that in mole, like before mole, I would like to discuss about dozen, because dozen is normal thing. So if we have 1 mole or 1 dozen banana is compared to 1 dozen cars. If somebody have 1 dozen bananas and another person have 1 dozen car, so by conceptually or normally we know that weight of 1 mole banana and weight of 1 dozen banana and weight of 1 dozen car, the car weight will be maximum than weight of the banana. So the same is that for mole. So 1 mole hydrogen, 1 mole nitrogen, or 1 more carbon, that is common atom, or 1 mole oxygen, or 1 mole Na. So in 1 mole of hydrogen we have 6.023 multiplied 10 raised to the power 23 atoms of hydrogen. So in same way 1 mole carbon mean 6.023 or Na number of carbon, and 1 mole oxygen mean Na number of oxygen, and 1 mole sodium mean Na numbers of sodium. But if you want the relation between mole and mass, so 1 mole hydrogen must weight something and 1 mole carbon is the weight something else. So the weight of 1 mole hydrogen, carbon, oxygen and sodium are different for each other. So what is the relation between the mole and mass? So 1 mole of atoms have atoms equal to its atomic weight, and 1 mole of compound, molecular compound or a ionic compound its molecular weight or molecular mass. So for example, if we have 1 mole of hydrogen, in this case if we have 1 mole hydrogen, so atomic weight of hydrogen is 1, and for H2 this is 2. So 1 mole hydrogen mean 1 gram. So 1 mole hydrogen is equal to 1 gram, and 1 mole carbon equal to, is carbon molecular mass is 12, so 1 mole carbon is 12 gram, and 1 mole oxygen is 16 gram. Now for H2O, 1 mole H2O means, if we have 1 mole H2O, it means that its mass is, hydrogen is 1 multiplied by 2, oxygen is 16, so it is 18 gram. If we have 1 mole NaCl, we can say that its weight is, its molecular mass from table is 30, from Cl is 35.5, so its weight is 58.5 gram. So 1 mole of substance have same number of that atom, but it actually mass different. Now here to write again, 1 mole of hydrogen weighs 1 gram, and 1 mole carbon weighs 12 gram, 1 mole oxygen weighs 16 gram, 1 mole Na weighs 30 gram, and 1 mole H2O that has Na molecules of H2O, but its weight will be equal to 18 gram, and like 1 mole NaCl, Na molecules of NaCl, and its weight will be 58.5 gram. So this was the relation between mole, its number and its mass for different atoms and compounds. Next on, we are going to write 2 to 3 MCQs on this thing, and then we will go further for stoichiometry. Use number first, here it's based on mole, so we will solve it. Which one is true for mole? Its counting number, its gram atomic mass of substance, it contains 6.023 to the power 23 atoms, or it contains different number of particles for different substances. So let's start from option A, its counting number. So yes, we know that mole is the counting number that is used for 6.023 multiplied 10 raised to the power 23 similar things. Now its gram atomic mass of substance, yes we know for hydrogen its 1 mole is 1 gram, because 1 gram is its atomic mass. For Cl 35.5 is its atomic mass, so it is atomic mass of that substances. So for each substances 1 mole is that gram atomic mass of that substance. Now a third is it contains 6.023 multiplied 10 raised to the power 23 atom. So yes it is, and this number is also called Avogadro number. It contains different number of particles for different substances. It contains different number of particles for different substances. No, it's totally wrong, because it contains same number of particles for different substances, because it doesn't depend on substance. If hydrogen, carbon, oxygen, sodium, water, NaC, whatever the substance is, but it is the term that is used for only 6.023 multiplied 10 raised to the power 23 atoms. So the option D is wrong. So MCQ is 1, which one is not true for mole? So option D is not true. They can also give this MCQs is that which one is true. So in this case that may give option A is given above, option B is given above, option C is same as above, and if they give option D is all of these. So as these three are right, so option D will be also right. Now we know that number of moles have two formulas. Number of moles is equal to mass divided by molar mass, or number of moles is equal to number of particles divided by 1 mole particle, that is equal to NaR 6.023 multiplied 10 raised to the power number of particle are divided by 6.023 multiplied 10 raised to the power 23. Now to solve MCQs on these, MCQ number 4 is 60 gram sodium hydroxide weight is equal to 2 mole. Now given is 60 gram, that becomes the mass. Now sodium hydroxide, from sodium hydroxide which means that NaOH, its molecular mass is Na equal to 23, oxygen is 16, hydrogen is 1, so that becomes 40. Now by formula we know that number of moles is equal to mass divided by molar mass, where mass is 60 gram divided by molar mass is 40 gram. 0 is 0, 4 2s are 6, 2 remain 20, and 4 1s are 4, sorry, 2 remains, and 4 5s are 20. So 1.5 is the answer. So option B is correct. Now MCQ number 5 is mass of 0.5 mole of calcium carbonate. So given is number of mole, to point is mass. Now we also know that the compound is calcium carbonate. Formula of calcium carbonate is CaCO3. Ca mass is 40, carbon is 12, oxygen is 16, into is 3 oxygen, so we will multiply it by 3, that become 48. 48 into 40, 48 into 12, 60, 60 into 40, 100. So its molecular weight is of calcium carbonate is 100, that is denoted by M. So we know that number of moles is equal to mass divided by molar mass. The number of moles is equal to 0.5, mass we have to point, and molar mass is 100, that equal to mass is equal to 0.5 multiplied by 100, or 1 by 2 multiplied by 100, that is equal to 50 grams. So option C is correct, and here option B was correct. Now we will solve 2 to 3 MCQs for further learning and confirmation. So here are 4 MCQs that we are going to solve on topic number of moles. So MCQs number 6 is an experiment. 85.50 multiplied 10 raised to the power 25 of water molecule were used. Its in mole is. So in experiment there were experiment done in which water molecule is used, and we have given the number of atoms of water molecule, and we asked to point number of moles. So what is the relation? The relation is number of moles is equal to number of particle divided by Na particle, or 6.023 multiplied 10 raised to the power 23. So number of particle is 8.50 multiplied 10 raised to the power 25, and this is equal to 6.023 multiplied 10 raised to the power 23. As the answer is solved, so we will ignore 8.5 and 6.023 for our easiness. So we know that 6 ones are 6 and 2 remain 20, 6 3s are 18. So 1.3 multiplied 10 raised to the power, this 23 will go upward, so it will become minus 23, and we will again multiply 10 raised to the power 2. So option is 1.3 multiplied 10 raised to the power 2. So we will get, as there is no 1.3, so we will choose 1.4 because we have ignored the terms 0.5 here in this case. So 1.4 multiplied 10 raised to the power 22 is correct answer. So answer 1.4 multiplied 10 raised to the power 2 here it is. option B. Now the next MCQ is weight of one carbon atom is. We know that atom is present in the world, so what will be its weight? So for solution we know that number of moles of carbon equal to, we know that 1 mole carbon, if we have 1 mole carbon is equal to this mass of carbon atom, so it is 12 gram. Further we know that 1 mole of carbon mean that 6.023 multiplied 10 to the power 23 carbon equal to 12 gram. So we have asked for 1 carbon, so how much will be its weight? So simply we will use cross multiplication. If 6.023 multiplied 10 to the power 23 carbon atoms 12 are 12 gram, so 1 carbon will be how much? So we will use cross multiplication. Simply the whole chapter is based on cross multiplication. So x multiplied by 6.023 multiplied 10 to the power 1 multiplied by 12 is equal to 12. So x is equal to 12 divided by 6.023 multiplied 10 to the power 23. So this will be equal to 6 2s are 12 multiplied 10 to the power, it will go upward, so it will become minus 23. So option is 2 multiplied 10 to the power minus 23, that is option B. So further MCQ number 8 is weight of one H2O molecule is. So we know that 1 mole of H2O is 6.023 multiplied 10 to the power 23 atoms of H2O molecule weights, its molecular mass, it is 18 gram. So if we want to find which H2O molecule its mass is x, so by cross multiplication x into 6.023 multiplied 10 to the power 23 is, this is the use of Na. Instead of this number we can simply write Na for easiness of calculation. X multiplied by Na is equal to 1 multiplied by 18, that is 18. So x is equal to 18 divided by Na. As the answer is solved, so we will solve it. 18 divided by 6.023 multiplied 10 to the power 23, this will go upward, it will become minus 23, and 6 3s are 18. So the option is 3 multiplied 10 to the power minus 23. 3 multiplied 10 to the power minus 23. MCQ number 9 is weight of one oxygen molecule is. So now this is same as this, but we have oxygen molecule. So Na atoms of oxygen has weight of oxygen molecule mean O2. So 1 Na atoms of oxygen is 32 gram. So 1 oxygen equal to x. So by cross multiplication x into Na equal to 32 into 1, or x is equal to 32 divided by Na. So the option is 32 divided by Na. Done. Further we are solving MCQ number 10. MCQ number 10 is number of molecules in 22 gram of carbon is. 22 gram of CO2 is. So we know that number of moles for any atom or molecule, in this case number of moles for CO2 is equal to molar mass of CO2, that is 12 plus 16 0 2 30. So 32 is equal to 44 gram. So we know that 1 mole of CO2 or 1 mole CO2 is equal to 44 gram, that's molecular mass of CO2. Further we know that 1 mole of any molecular compound is equal to 6.023 into 10 to the power 23 atoms. Now we know that 1 mole CO2 equal to 44 gram is equal to 6.023 multiplied 10 to the power 23 atoms of molecules of CO2. So as 1 mole or 44 gram of same is same, so 1 mole is equal to 44 gram is equal to the. So if we point at this is in 44 gram we have Na atom. So in 22 gram we have how much atom? So By cross multiplication, we will get x multiplied by 44 gram is equal to 22 multiplied by 6.023 or Na, or x is equal to 22 by 44 multiplied by Na. 22 by 2 is equal to 44 and Na divided by 2, where Na is equal to 6.023 multiplied 10 raised to power 23, and this divided by 2 is we will get 3.011 multiplied 10 raised to power 23. So option 3.011 multiplied 10 raised to power 23 is correct option. Now, the largest number of molecules is present in 22 gram CO2, 98 gram H2SO4, 36 gram water and 180 gram of C6H12O6. So, for carbon dioxide, we know that 1 mole CO2 is equal to 44 gram because CO2 molecular mass is 44. The next is for H2SO4, its molecular mass is 2 gamma 62 into 68 is equal to 98 gram, and that for water is 1 mole equal to 18 gram. Here is 36 gram, so 36 gram is 2 mole, and glucose 1 exhaust C gram is, for glucose molecular mass is 80, so 180 gram is equal to 1 mole. So R are the given option are, this is 1 mole carbon, 1 mole H2SO4, but water is 2 mole and 1 mole C6H12. So 1 mole is Na atoms, 1 mole H2SO4 is also 1 Na atoms, 1 mole C6H12O6 is Na atoms, but 2 mole of water is 2 multiplied by Na. So 2 multiplied by Na, this is the largest number of molecule present in 36 gram of H2O.